All right, we're going to continue our work with exponents, and this time we're going to move into zero and negative exponents here on lesson 5. So when you talk about zero and negative exponents, a lot of people have the mistaken idea that like 5 to the 0 is 0, all right? But it's not. Anything to the 0 power is 1. I don't care if it's 5 to the 0 power, x to the 0 power, maybe it's 87 million to the 0 power. And this is why that is. Whenever you have something, let's just say like a general fraction, let's say 4 over 4, you know that anything divided by itself is 1. 4 over 4 is 1. 7 over 7 is 1. Works the same thing with letters. X over x, something divided by itself, is 1. Would work the same way if I put exponents on these. Let's say 4 squared divided by 4 squared. Doesn't matter what the number is, as long as it is something divided by itself. Okay? Now, we also had some quotient rules for exponents a few lessons ago, and the quotient rule said that as long as they have the same base, like 4, as long as they have the same bases, you can subtract the exponents. So this would be 4 to the 2 minus 2, which would be 0. Now, what did we just say that something divided by itself was? 1. So this is why anything to the 0 power is 1. This 7, you do not see an exponent, you assume it's a 1. So the answer to this is 7 to the 1 minus 1 power, so 7 to the 0 power. And we just said that something divided by itself was 1. So anything divided by itself is 1. Now, let's talk about negative exponents. It says right here in the definition, any non-zero number to the 0 power is 1. That's what we just did. Any non-zero number to a negative power is the multiplicative inverse. Now, multiplicative inverse is a fancy word for reciprocal. And you remember reciprocal is a flipped fraction. So if we talk about 7 to the negative 3 power, well, 7 to the negative 3, you know that you can put anything over 1, right? And so the reciprocal of that would just be to switch these. Top goes to the bottom, bottom goes to the top, which makes it 1 over 7 to the 3rd power. 1 over 7 to the 3rd power. The exponent does go to positive. All right, 1 over 7 to the 3rd power. So if it was 2 to the negative 2, how do you write that with positive exponents? It would be the reciprocal, 1 over 2, exponents positive. 5 to the negative 4th power. 1 over 5 to the positive 4th power. Works the same way with letters. N to the negative 8th power would be 1 over n, so the reciprocal of that, exponent goes to positive. We had one like this in, I believe it was 1.1 homework, if you had to do the second 1.1 homework. And it had, if you remembered, it was a pattern. And it said like 3 to the 3rd power was 27. 3 squared is 9. 3 to the 1st was 3. 3 to the 0 power, well, we just learned to the 0 power, anything to the 0 power is 1. But it said predict what is 3 to the negative 1st power. Well, look and see what's happening here. Every time you go down an exponent, you go down an exponent of 1, what's actually happening to the numbers here? 27 to 9, 9 to 3, 3 to 1. What are you actually doing there? So if you're going down an exponent, the answer is actually being divided by 3. Divided by 3. So if I take this, which was my last answer, and divide it by 3, it will be 1 divided by 3. Now, doesn't that fit the examples that we've just been doing here? It is the reciprocal. So 3 over 1 changes to 1 over 3, and the exponent becomes positive. That is why that rule works. That is why that rule works. Now the shortcut to that is the reciprocal and change the sign of the exponent to positive. But this is why that rule even exists. So on the examples here, number 1. It says write each expression using a positive exponent. Well, 6 to the negative 3, 1 over 6 to the positive 3. A to the negative 5th, 1 over a to the 5th. Reciprocal, make the exponent positive. Okay, now under got it, why don't you try A, B, C, D, pause it, and then come back for the answers. If you did these, and hopefully you did them correctly, you've got 7 to the negative 2. 7 to the negative 2 would be 1 over 7 to the positive 2. B to the negative 4th, 1 over b to the positive 4th. Anything to the 0 power is 1. Those are the easiest ones on the page because you don't really have to do anything with them. M to the negative 3, 1 over m to the 3rd power. So anytime you see a negative exponent, reciprocal, change the exponent to positive. Okay. Next examples. Write each fraction as an expression using a negative exponent other than negative 1. So if you've got 1 over 5 squared, this is the exact opposite of this one. This is saying it's already where it's supposed to be, and write it with an exponent, with a negative exponent. So if it's 1 over 5 squared, we can switch back and forth by taking the reciprocal. So 1 over 5 to the 2nd power, reciprocal of that would be something over 1, which we don't have to worry about writing the over 1 part. And the exponent changes signs once again. Anytime you take something from the bottom to the top or top to the bottom, the exponent will change. So 1 over 36. Exponent would be 36, sorry, the reciprocal would be 36 over 1, or just 36. 36. Now, it said exponent other than negative 1, and that's what that would be there. That would be 36 to the negative 1 power. Come on, pen. But it also said other than negative 1. So we have to write 36 as something else. So if you look at this, so it does not want this. It says 1 over 36. Now you can break 36 down into 6 squared. So instead of 1 over 36, it would be 1 over 6 squared, right? That would be something times itself to get 36. 1 over 6 squared, so whenever you do the reciprocal of that one, you now have 6 to the negative 2. Now notice on these, the only sign that changed was the sign of the exponent, right? The sign of the actual number did not change at all. So when you do these, make sure you are only changing the sign of the exponent and not the sign of the actual number. So I want you to pause it now and try E, F, G, and H. On E, if I write that as its reciprocal, I would have 8 over 1, so just 8. My exponent changes signs to the negative 3. F, if it wants something other than negative 1, I'm going to have to write 1/4 as 1 over 2 squared. So then when I rewrite that one over here, it would be 2 to the negative 2. This one, reciprocal of that, C to the negative 5th. Reciprocal, change the sign of the exponent. This one, other than 27 to the negative 1, which it says right here it does not want, I would write that as 1 over. Now, nothing squared is going to give you a 27, obviously, because it's an odd number. So you might have to think about other exponents. So especially since this is a small number, your base is going to be a very small number. Let's try 3. 3 times 3 is 9, times 3 is 27. So this would be 1 over 3 cubed is the same thing as 1 over 27. So I can now flip this one and make it 3 to the negative 3. And again, I want to point out that like on F and G, the base did not change signs. Only the exponents changed signs. Okay? Only the exponents. Whenever you do a reciprocal, only the exponents change. So let's look at these on the next page. One human hair is about 1,000th, 0.001 inch in diameter. Write the decimal as a power of 10. So 1,000th would be 1 over 1,000 as a fraction. So just like we did before, we need to break down 1,000 into a power of 10. So it is 10 times 10 times 10. So reciprocal, change the sign of the exponent. Okay. This one, we've got a bunch of zeros here. That would be the, let me get my pen back up here. Tenths, hundredths, thousandths, 10,000s, 100,000s, millions, 10 millions, 100 millionths, billionths, 10 billion. So it would be 1 over 10 billion. You're writing that as a power of 10. It would be 10 to the, you have 9 10 zeros, so it would be 10 to the negative 10th power. All right. Quickly, let's move on to the multiply and divide with negative exponents. Multiply and divide with negative exponents. So let's look at our examples here. We know about the quotient rule and the product rule. We know that anything that has the same base, you add the exponents. If it has the same base, you add the exponents. The only problem is now you've got 3 plus a negative 5, which for most of you, that shouldn't be a problem. 3 plus a negative 5, you remember that when the signs are different, you subtract and give it the sign of the bigger number. That is the reason why it's 5 to the negative 2. So 1 over 5 to the 2, 1 to the 25th. This one may be the one that causes you a little bit of problem. What you got to realize here is that it's division, so you subtract negative 1 minus a minus 4. Minus minus goes to a plus plus. Negative 1 and 4 would be w cubed. So trying j through m. Go ahead and pause that. Let's look at j. Same base, so we add the exponents. So j would be 3 to the negative 6th, which would be 1 over 3 to the 6th. Now you can go ahead and multiply that out if you wish, but you do not have to. K, that would be 11 to the negative 2. 2 minus 4 is negative 2, or 1 over 11 squared. You do have to write them with a positive exponent because that's the most simplified version. L, n to the 9th times n to the 4th. You subtract those, n to the 5th. And the last one, it would be negative 4 minus a minus 7. Minus minus is a plus plus, b to the 3rd. All right. Looking at a couple of examples under guided practice. Number 1, write each expression using a positive exponent. So 2 to the negative 4th, 1 over 2 to the 4th. 4 to the negative 3rd, 1 over 4 to the 3rd. A to the negative 4th, 1 over a to the 4th. G to the negative 7th, 1 over g to the 7th. No base change signs, just the exponent. Write each fraction as expression using negative exponents other than negative 1. So this would be 3, reciprocal, exponent changes sign. Reciprocal, exponent changes sign. Now, those had a one other than 1. So this one, 2, actually be 1 over 2 to the 4th power. So that would be 2 negative 4th. This is 7 squared. 7 to the negative 2. Okay. So on that, I think we should be good to go. Let's go ahead and look at 10 and 12. Sorry, 10 through 12. 10 through 12. Add the exponents. 3 to the negative 5th power. 3 to the negative 5th, 1 over 3 to the 5th. R to the negative 4th, because I'm adding exponents, 1 over r to the 4th. Last one, negative 2 minus a minus 12 plus, that would be p to the 10th power. Okay, any questions? Let me know tomorrow.